here is a line. In fact, it's the same line used at the beginning of the previous lesson. And just like the previous lesson, we're going to mark the points that have integer coordinates. The previous lesson was about slope, and we counted from consecutive marked points the vertical change and the horizontal change. And in this line, it was 2 up and 3 to the right for a slope of 2/3. But another way to do it is to find the coordinates of those 2 points. And these 2 points, the first one has coordinates of -6 and -9, and the second one, going from left to right, has coordinates of -3 and -7. And then we do a little arithmetic, and we find the difference first between the 2 y coordinates. In this case, -7 take away -9, which is 2. Then we find the difference between the 2 x coordinates. In this case, -3 take away -6, which is 3. And we still get that the vertical change was 2 and the horizontal change 3 for a slope of 2/3. We pick 2 other points on the line. We find the difference in those points. First, the difference in the y coordinates. In this case, -1 take away -7, which turns out to be 6. And then the x coordinate difference, 6 take away -3, which turns out to be 9. And then our horizontal is 6, our vertical is 9. Lowest terms, 2/3. We're happy because the slope of this line is 2/3, no matter which 2 points you pick. We'll do one more, and this one, we went 10 down and 15 to the left the first time when we counted it out. And doing it this new way, we find the difference, 1 take away -9, which is 10 for the vertical difference, and 9 take away -6, which is 15, the horizontal difference. We make that a fraction, we put it in lowest terms, and once again we get 2/3. It's time to look at another line. We pick 2 points on this line, and if we counted, it's 4 down and 16 to the right. If we find the difference vertically is -4, and the difference horizontally is 16. And we make that a fraction and put it in lowest terms, and we get -1/4. We pick 2 different points, going from the point on the right to the point on the left, 2 up and 8 to the left. Now we find the difference. The vertical difference then is 3 take away 5, which is -2, and the horizontal difference is 3 take away -5, which is 8. We make it a fraction, -2/8, put it in lowest terms, and again, we get -1/4. And that brings us to this, the slope formula. You might have figured that having to find the slope by counting on graph paper might not be the only way, and it's not. If you can find the coordinates of 2 points on a line, you can apply this formula. And I don't know why they use the letter M for slope, but there it is. The letter M often stands for the slope. And the other thing we're seeing here is something called subscripted variables. It's pronounced x sub 1, y sub 1 for the first ordered pair, and x sub 2, y sub 2 for the second ordered pair. I sometimes just say x number 1 and y number 1. But if you've never seen subscripted variables before, you will probably see them many times in the future. And they're just used so that we can tell these 2 points apart, because we know that a line contains infinite ordered pairs, x and y. So we use the subscripts to identify the points that we want to choose to work with on any given line. Well, let's use the slope formula for these 2 points. We don't even need to see the graph now. We can just apply the formula. And what I often do is write down the x sub 1 and y sub 1 and the x sub 2 and the y sub 2 so that I can keep track. Then I substitute it back into the formula, getting this. I choose to apply the definition of subtraction. Then I do the arithmetic, and then I put it in lowest terms. The slope of the line containing these 2 points then is -2/3. Here's the same pair of points, but this time we've labeled the first pair as x sub 2, y sub 2, and the second pair as x sub 1, y sub 1. And the reason we're doing that is because the designations of which pair is number 1 and which pair is number 2, That's an arbitrary designation. So we're going to do the problem this time in reverse. So our numerator now is 4 take away 8 instead of 8 take away 4. Our denominator is 5 take away negative 1 instead of negative 1 take away 5. We apply the definition of subtraction. We do the arithmetic, and this time we get negative 4 over 6. The previous time we got positive 4 over negative 6, but both fractions simplify to be negative 2/3. In fact, the formula could be written as y sub 1 take away y sub 2 in the numerator and x sub 1 take away x sub 2 in the denominator. But every textbook that I've ever seen always does the formula the way you see it at the top. Y sub 2 take away y sub 1 on the top, x sub 2 take away x sub 1 on the bottom. But it really doesn't matter the order. What does matter, if you do y sub 1 take away y sub 2 on the top, make sure you do x sub 1 take away x sub 2 on the bottom. That's important, or you'll get the opposite of the correct slope. Here's another example. We mark them, we plug them in, we apply the definition of subtraction. We do the arithmetic, we put the fraction in lowest terms, and the slope of the line containing these 2 points is negative 5/3. And another example. This example is special because both the values for y are the same, negative 5. So we take a look at the problem, and any number take away itself, of course, is 0. I've chosen to apply the definition of subtraction, so it's negative 5 plus its opposite, but it's still 0. And we know from the previous lesson that if the numerator is 0, the slope is 0, and that, of course, is a horizontal line. And in this example, the two x values are the same. They're both 7. And of course, we know that 7 take away 7 is 0. I go to the trouble of using the definition of subtraction, but we know that 7 take away 7 is 0. And we know that negative 4 divided by 0 involves division by 0, which is undefined. So this line has no slope, as mentioned in the previous lesson. And of course, if you remember the previous lesson, this is a vertical line, and its equation would be x equals 7. Where the slope formula really comes in handy is when you're given coordinates that are not integers. These would be very difficult to count out on a piece of graph paper. So we definitely want to use the slope formula here. We mark out our subscripts so we can plug them into the formula. I would probably use a calculator here, but if you're not able to use a calculator, I recommend the definition of subtraction. Then get pencil and paper out and do the problem. Now to put this in lowest terms, multiply both the numerator and the denominator by 100. And I also took the negatives away because we know that negative divided by negative is positive. And finally, I look at those two numbers and they're both divisible by 4. So my fraction in lowest terms for the slope here is 5 over 67. This is the type of problem where the slope formula is pretty much mandatory. It would be nearly impossible to get an exact answer trying to count this out on graph paper. To summarize then, the slope formula, given the coordinates x sub 1 and y sub 1 and another pair x sub 2 and y sub 2 that are 2 points on a line, the slope m of the line is that m is equal to y sub 2 take away y sub 1, all of that divided by x sub 2 take away x sub 1.